a raised to x as b. This is an exponential form. And when you write it in logarithmic form, you will write log of b to the base a is equal to x. So one example of that is 3 raised to 4 is 81. So log of 81 to the base 3 is equal to 4. And then you have rules of logarithm. So log of a into b is equal to log a plus log b. Then you have log of a upon b is log a minus log b. Then you have log of a raised to m is m log a. Log a to the base a is 1. Log of 1 to any base is 0. And when you have log a to the base b, that is log a to base c upon log b to base c. So this is called as change of base. Limit x tends to infinity, 1 plus 1 over x raised to x is e. Then you also have limit x tends to infinity, 1 plus a upon x, and here you have x upon a, that is e raised to a. And then limit x tends to 0, e raised to x minus 1 upon x. This gives you 1. Limit x tends to 0, a raised to x minus x upon a. This is equal to ln a. Then limit x tends to 0, 1 plus x raised to 1 upon x is e. And limit x tends to 0, ln 1 plus x upon x is equal to 1. So these are some of the properties that we will be using. You can write this down before we move ahead. So the first question here, limit x tends to 0, e raised to 4x minus 1 upon x. Limit x tends to 0, e raised to 4x minus 1 upon 4x. And then we have to multiply by 4 as well. So taking the limit, we get 4 into 1. The answer is 4. And similarly, there is the second subpart, limit x tends to 0, 3 raised to x minus 1 upon x. So here there is a direct answer. It will be ln of 3. Okay, so in this question, students, if it was something like e raised to 5, then we would have to multiply this, and then the answer would be 5 times ln 3. So I have limit x tends to 0, e raised to x minus 1 upon x. So if you compare it with the formula that we have just used, okay, so knowing the rules is very important. So I can write this. So this is e raised to x, x. This is x upon x. Here we can write, since x approaches 0, x is not equal to 0. So we will have limit x tends to 0, e raised to x minus 1 upon x. And this is limit x tends to 0 and 1. Now taking the limit, this gives me 1, this is 1. So the answer is 0. Limit x tends to 0. This is x e raised to x minus 1 upon 1 minus cos 2x. If you go by the formula, what do you need below this? You need a x below this, right? And when you see 1 minus cos, what comes to your mind? 1 minus 2 sine square theta. So 2 sine square theta is 1 minus cos 2 theta. Okay, how do we proceed? Now this is limit x tends to 0. This is e raised to x minus 1. I need a x below. So if I put a x below this, I will have to multiply with a x. Now 1x is already there, so that I am writing it here. And 1 minus cos should give you 2 sine square, half angle. This is 2x, so it becomes x. Okay, so this is 1 here. So I'm writing this as limit x tends to 0, e raised to x minus 1 upon x. And there is a x square. And here you have sine square x. And this too is carried away. Just let us write it in a little neat manner. So this is x. This is x upon sine x the whole square. And this is a half. Now taking the limit, you get this as 1. you get this as 1 square and this as half. So the answer to this question is half. It is similar to what we have just done. This is x, this is 2 raised to x minus 1, and this is 1 minus cos x. So again, this is 2 raised to x minus 1. We need a x below, so we multiply, and here you have 1 minus cos. So that will be 2 sine square x by 2. Yeah. So this is half angle. So limit x tends to 0. This is 2 raised to x minus 1. So this is not a problem. You have x square upon sine square x by 2. And this is a half. Okay, so the square of the angle should be there. So you need a 1 by 4. So you will multiply by a 4. Okay, so that will make you write this as x tends to 0, 2 raised to x minus 1 upon x, sine x, this is x by 2, sine x by 2 the whole square, and this is 2. So taking the limit, you get ln 2, you get 1 squared, and you have a 2. So this 2 ln 2 is the answer. This 2 is a part of the formula. 1 minus cos is equal to 2 sine square x by 2. So this 2 I have written on the side. This is e raised to x minus sine x minus 1 upon x. So we write it separately as e raised to x minus 1 upon x minus sine x upon x. So now if you take the limit, this gives you 1, and so does this. 0. So the answer is 0. And the fourth part is also pretty straightforward. Limit x tends to 0, e raised to x. So we have to take the limit. Taking the limit. So e raised to 0, the answer will be 1. So here there is one step at the beginning. X tends to 0, e raised to ax. This is bx, and this is x. So if I'm subtracting 1, I have to add 1 as well. So it doesn't change the question. Now again, our idea is to make it look something like that. So keeping that in mind, what I can do, this is e raised to ax. I will transfer that minus 1. This is e raised to bx, and I write a plus 1 here. So this is limit x tends to 0, e raised to ax minus 1. I take this x below that, and this negative, if I take it out, I'll get e raised to bx minus 1 upon x. Okay, now we know, yeah, so whatever is over here needs to be repeated. So there is a and there is a. So I'm multiplying a up and down, same with b. Okay, so now we have what we require. So we can take the limit. So we get a into 1, b into 1. So the answer is a minus b. E raised to x minus is 1. So over here, if this is a, it will still be 1. And what we have done in our previous questions was, the question had already had a over there. So we had to write a. So this gave you 1, and this a remained. So that's why the answer was a for us. But if the question already has a ax and down also it has ax, then the answer will just be 1. Like in this particular case, this gave you 1 and this a remained over.